Okay, we're going to look at the sum of an AP proof. Okay, an AP starts off like this. So the sum, the first term is A, the second term is A plus D, the third term is A plus 2D, and I can keep going, I can't be bothered. So what I'm going to do is I'm going to put in the very last term, which I'm going to call L, and then I'm going to put in the term before that, which is L minus D, and, oh, shall I squeeze in the next one? No, can't be bothered. Yeah, go on then, let's do it. L minus 2D squeezed into there with some pluses, and it must go plus dot 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 plus. Okay, then what I'm going to do is I'm going to rewrite the proof underneath. So, sorry, not the proof, the sum. So what I'm going to end up with is I'm going to write the first three, I'm going to reverse them. So I'm actually going to write them here. So A will go there, and A plus D is going to go here, and A plus 2D. There's a plus in there, that was just quite squeezed in. And then the ones at the back, here's the ones at the back. So I'm going to reverse them, and I'm going to write them this way round. So last plus L minus D plus L minus 2D. Plus dot 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 plus. Okay, now I'm going to call this one number 1 and this one number 2. And what I'm going to do with them is I'm going to add them together. And I want you guys to just remember that, because you're going to have to prove the GP proof in C2, but the sum of an AP means that we are adding. Right? Can you see that they've both got an A in them? So the sum of the AP means we're adding. So if we add these two together, we're going to get 2 lots of S and N. And then what we're going to do is we're going to add these in pairs. So we're going to get A plus L. And then look what happens here. Add those two. Notice the D's will cancel, and we're still getting A plus L. And then if we add these two, the 2D will cancel with the minus 2D, and we're still getting A plus L. If we look to the back, that will give us A plus L. These ones, these two D's will cancel, that will give us A plus L. And these ones, these two D's will cancel, and that will give us A plus L. So, how many A plus L's are we left with? Okay, if there were 5 numbers in the sum, we would have 5 A plus L's. If there were 10 numbers, we'd have 10. So I've got n numbers in my sum, so I'm left with n lots of A plus L. Okay, next thing I'm going to do is divide both sides by 2, so I'm going to end up with n over 2, first plus last. Right, now that is the sum formula, but they're going to want us to take us a little bit further. Okay, when we looked at this... Oh, look at that. When we looked at, hang on, this bit here, the last term here, the one on the end, what we found was that the last term is also known as u to the n, and u to the n is a plus n minus 1d. So what I'm going to do is I'm going to replace this last term with a plus n minus 1d. So I'm going to get n over 2, so the sum is n over 2, a plus n minus 1. Oh, sorry, n minus 1, d. Okay, let's see what we get when we neaten all of that up. The sum is n over 2, 2 a's. Can you see those two will go together to give you 2 a's? Let me show you, there they are, 2 a's plus n minus 1 d. And that is the proof of a sum of an AP.